This will be for the con exercise, derivatives of inverse functions. All right, so you want to remember inverse functions. The x-coordinate of one function equals the y-coordinate of the other function, and vice versa. So if f and g are inverse functions, that means the x-coordinate of f equals g of x, and the x-coordinate of g equals f of x. Remember, g of x is the y-coordinate of g, f of x is the y-coordinate of f. For their derivatives, f prime of x equals 1 over g prime of f of x, and g prime of x equals 1 over f prime of g of x. So if you want to see where these derivatives came from, recall that for inverse functions f and g, f of g of x just equals x. Okay, if you plug in x in the inner function and evaluate that at the outer function, it will just return the same value of x. And what you want to do for this here is take the derivative with respect to x on both sides of the equal sign. All right, and remember, this is a composite function. So when you take the derivative of a composite function, it's the derivative of the outer, leave the inner function alone, and then times the derivative of the inner function. And on the other side of the equal sign, the derivative of x is just 1. So let's say you wanted to solve for the derivative of g prime of x. These are all multiplied. The opposite of multiplying is dividing. And you have f prime of g of x, and also divided by, on this side, f prime of g of x. Cancels here. And we have g prime of x equals 1 over f prime of g of x. All right, so that's what we said right here. And you can do the same exact thing if you have g as the outer function and f as the inner function. And you'll get this one right here. All right, the way I remember it is 1 over the derivative of the inverse of the original. Okay, so if you're doing the derivative of f, you take the derivative of the inverse g, and that is of the original function f. All right, so we have g and h inverse functions, and we have a table right here for x equals 3 and x equals 4, and they want us to find h prime of 3. All right, since we're finding h prime of 3, let's start with h prime of x. We said the derivative is going to be 1 over the derivative of the inverse function of the original function h. All right, so we're looking to do h prime of 3. So we're subbing in x equals 3. That's going to be 1 over g prime of h of 3. And that's going to be 1 over g prime. And evaluate this function at h of 3. Here's x equals 3. And if we find h of 3, that's going to be 4. All right, so this right here is 4, so we're looking for g prime of 4. That's going to be 1 over g prime of 4. This right here is x equals 4. And if we go to g prime, that's just 1/2. So it's 1 over 1/2. All right, keep, change, flip. Keep 1, change division to multiplication, and flip the denominator. 1 over 1/2 is just 2. All right, here we're trying to find h prime of 4. They give us some information. So let's start with h prime of x. And that's going to be 1 over the derivative of the inverse function, which is g, of the original. So that's h of x. All right, and we're evaluating this at x equals 4. So we're just going to plug in x equals 4 for now. All right, so this is going to be 1 over g prime of h of 4. Now, how do we find h of 4? Well, remember the x and y coordinates are just swapped when the functions are inverse of each other. So if g1 equals 4, that means h of 4 equals 1. Okay, this is the x coordinate of g and the y coordinate of h. And then if you swap it around, this is the x coordinate of h and the y coordinate of g. So this is going to be 1 over g prime of h of 4, and we said h of 4 is just 1. All right, so now we just need to find g prime of 1. How do we do that? Well, we have the g function right here. It says g of x equals x to the 5th plus 3x. If we take the derivative of that, power rule on x to the 5th, move the 5 out front. That's 5x to the 4th. And the derivative of 3x is just 3. And now we want to find g prime of 1. Well, you just sub in x equals 1. So that's going to be 5 times 1 to the 4th plus 3. 5 times 1 to the 4th is 5, plus 3 is just 8. So that's going to be your g prime of 1. And that's just going to be 1 over 8. Final answer. All right, just real quick, just so you understand this part here, g of 1 equals 4. That means on the g function, x equals 1 and y equals 4. But since these functions are inverses, that means on the f function, it's going to be reversed. And x equals 4 and y equals 1. So that's what I did right here. X equals 4 and y equals 1. I just switched them because these are inverse functions. All right, one more. H of x is this function. F is the inverse. Notice that h of negative 1 equals 10. All right, since f is the inverse, we might as well write it out right here. If h of negative 1 is 10, that means f of 10 is going to equal negative 1. All right, since we're looking to find f prime of 10, let us begin with f prime of x. All right, for the inverse function, it's going to be 1 over the derivative of the inverse, so that's h prime of the original, so that's of f of x. All right, since we're evaluating at x equals 10, we're going to do f prime of 10, and that equals 1 over h prime of f, and x equals 10, so it's going to be f of 10. All right, that's going to equal 1 over h prime. And we said f of 10 right here. We said f of 10 is negative 1. And now we just need h prime of negative 1. Well, we have the function h right here. All right, h of x is 7 minus x minus 2x to the fifth. We need h prime, so we're going to take the derivative. Derivative of 7 is 0. The derivative of negative x is negative 1. And use the power rule right here. Move the 5 out front. That's going to be negative 2 times 5, or negative 10. Decrease the exponent by 1. That's x to the fourth. Okay, and now sub in negative 1 for h prime of negative 1. That's going to be negative 1 minus 10 times negative 1 to the fourth. All right, negative 1 to the fourth is just positive 1 times negative 10. That's still negative 10, and negative 1 minus 10 is going to be negative 11. All right, so this right here is negative 11. So that's 1 over negative 11. All right, so just click in the box and type negative 1/11. All right, negative in the denominator, same as a negative in the numerator.